Leetcode problem 7, reverse integer. So for this problem, we are giving a side 32-bit integer x, so we're going to return x with its digits reversed. If reversing x causing the value to go outside of the side 32-bit integer range, it means if it goes out of the range, we're going to return 0. Yeah, and we should be careful that we should assume the environment does not allow you to store 64-bit integer side or on side. So this means we have to use an integer. Yeah, so the easiest way to solve this problem is by using Java. It is much easier than Python. Yeah, because for Python, basically, there's no something like integer or long integer, but in Java we have. So this means we cannot use long as the integer type to solve the problem. We have to use the integer. Yeah. So now let's just use the basic idea to solve it. So we're going to prepare the final result, and we just needed to check if this value, current value x, not equal to 0. We're going to update the final result, it times 10. So this is going to be a basic formula. Yeah. And x is going to be divided by 10. And finally, we're going to return the result. If there's no overflow, everything should be okay. Yeah. But what happens if there is overflow? Why I did it wrong? Yeah, because here I did x modulo x, it's going to be x modulo 10. My formula is wrong. Yeah. Now as you can see, everything works. But currently we are not checking overflow. But if there's overflow, definitely it didn't work. Yeah, so for example, for this example, so there's going to be an overflow. Why? Because this is 1. If we reverse it, it's going to be something like 964. But in Java, this is just integer. It cannot store a bigger value than this digit should be 2, normally the biggest value, but it is 9. Definitely it didn't work because it cannot store such a bigger value. So this means we need to have the overflow check. But we cannot store any variable as long in Java we have to use integer, right? Yeah. So here basically we need to have a check, and later on I'm gonna explain why this check gonna always work. Yeah. So if this result, currently this result is just an integer type, it cannot be long. So if this is less than, so inside Java we're gonna use this method from the integer class, integer dot mean value. If it is less than integer dot mean value, or the result is more than integer dot similarly, we can use the max value. If it is yeah, so this is for checking the overflow. If there is overflow, we're gonna return 0. But currently, after this calculation, the result gonna be times 10 and plus x modulo 10. Yeah. But before that, we need to use this value divided by 10. And similarly, for the max value, it's gonna be divided by 10. Yeah. So let me just run it first, and later on I'm gonna explain why it works. Yeah. Yeah. So as you can see, it works. So just imagine this value divided by 10. It's gonna be definitely it's gonna be a smaller value. Yeah. Because after that, this value gonna times 10. It's gonna become bigger. So this means if this value result is an integer, if it is more than this value divided by 10, and then it times this value and plus the modular result, definitely it's gonna have overflow, and similarly for the negative value. Yeah. So let's just print out something to check. System.out.println. So we're gonna print something like mass power with minus 2 to the power of 31. So we're going to use an example to explain why this formula works. So after that, we can directly use this kind of formula to check the overflow. Yeah. system out dot println it's gonna be it's gonna be minus 2 to the power of 31. Yeah. Now we're gonna check this number. As we can see, this is gonna be this number minus 2 something times 10 to the power of 9. But let's just take out this number. So this means if it is a negative number, it's gonna be something like this. Yeah. As the positive number gonna be 2 to the power of something minus 1. So let's just check what's going to be the positive number. 2 to the power of 31 and minus 1. Yeah, so this is going to be the positive number. 2 to the power of 31 minus 1. This is going to be the maximum number for this positive number. Yeah. So let me remove the dot, and then we can analyze about it. Yeah. So for this positive number, as we can see it, if this is going to be the maximum number, so this is going to be the maximum positive number. This is going to be the max value. So this value going to be the max value. And for the first digit of this max value, it is a 2. Yeah. But this value can be something like 0 or 1. If 0, it means we don't have this value, or it can be 1 for the first digit of the maximum number. Yeah. But the maximum for this digit, if it is the maximum value, it must be 2. It cannot be 3 or something. If it is a 3, it's gonna be an overflow. Yeah. So the integer dot max value divided by 10, what is gonna be the result? It's gonna be this value. Let me just copy and paste. It's gonna be this value. Yeah. So this value is gonna be the integer dot max value divided by 10. Yeah. So currently, before we calculate using the formula, we need to have such kind of check. So this means if this result is bigger than this number, definitely it's gonna have an overflow. So which number gonna be bigger than this? Maybe, let me just copy and paste. Maybe this number adding with 5. So it is bigger than this number, right? Now, this is the smallest result. Yeah. It is the smallest result, right? So it is adding with 5. Now this value gonna times 10. Yeah, so it's gonna become adding with 0, and then we're gonna plus another number. Another number gonna be x modulo 10. It must be something from 0 to 10. Yeah. Now we just check this number. Is that gonna be an overflow? So definitely it is, because this number must be bigger than the maximum positive integer. This number, yeah, because this is 50, this is 47, so it must be an overflow. Yeah, this is why we use such kind of formula. But you might think, what happens if the result equal to a negative dot max value? Yeah, what happens if it is equal? So let's just use the check the equal case. So if it is equal, if the result is equal to the maximum value divided by 10, so this is gonna be my result. Let me just copy and paste. So currently this value, if it is a positive integer, this value gonna be the result, because result equal to this number. Yeah. So what happens at times 10? At times 10, going to be adding with 0, right? Yeah, it's going to be adding with 0 if it is equal. So just imagine if it is equal, yeah. But we're going to plus another value. Another value going to be x modulo 10. For our value, what's going to be the last digit after reversing? It must be this number 2, or it can be 1. Yeah, I mean the digit must be the maximum number as possible. So it can be 2 or it can be 1, but 2 gonna be the maximum number. So lastly, we're gonna plus this value. It's gonna be 2 modulo 10. It's gonna be 2. So we're gonna plus 2. So we got this kind of result if it is equal. So we just checking if it is equal. It's going to be this number. Yeah, it's going to be something like this number, but this number is less than the current number. It means it is not an overflow because this number is less than the maximum number. So this means we don't need to check the equal case. We just need to check if it is more than the integer dot max value divided by 10. We don't need to check if it is equal. Yeah, because if it is equal, definitely it is not overflow. If it is more than this value, it's going to be an overflow. And similarly for the negative integer. So this is going to be the negative integer. So this value divided by 10, it's going to be this number. Yeah. It's going to be this number, but if the result is less than this number, so here going to be a 5 because it is a negative integers. Now this value going to times 10, it's going to be 0. So definitely this value going to be smaller than our minimum value, minimum integer. So it means it's going to have an overflow. But what happens if it is less than or equal? If it is less than or equal, we can also solve it like this, because if it is less than or equal, it's going to be this kind of integer, right? 4 and with 0, and we just need to plus the last integer, and the last integer is going to be 2. So we're going to plus last integer, which is going to be negative 2. It's going to be 2 here. Yeah, so definitely this value is more than the minimum value. So it is not an overflow. So definitely we don't need to check the equal case. Yeah. So this is why we can directly check if the result is less than integer dot minimum value divided by 10, or result is more than integer dot maximum value divided by 10. We find it's going to be an overflow. So currently we didn't use any kind of long integer type. We only used the int. We didn't use long. As we can see, this is the int and this is the int, and there's no overflow. And now let me just run it and submit it to check if it works. Yeah, as you can see, it works. So there's a lot of mathematical calculation and mathematical proof for this problem. But as you can see, we just need to add one line to check the overflow, and everything gonna be okay. I think that's all about it. Thanks for watching. See you next time.